Hi students, in this video we are going to discuss about third equation of motion. Or velocity position, relation. Or velocity distance relation. Velocity distance relation, or v square minus v square minus v naught square is equal to 2as, or v square minus u square is equal to 2as. Now, once again I am repeating the concept, my dear students. In this video, we are going to discuss about third equation of motion, or velocity position relation, or velocity distance relation. We also call it as v square minus v naught square is equal to 2as, and also v square minus u square is equal to 2as. Now, this is the heading. Now go for the discussion. Consider a positive x-axis. It is O. It is positive x-axis, say x. Take 2 points. Here, initial consider displacement x0. After it move a distance x. Consider this is the, we are observing position O. After some time is t. Consider initial velocity v0. Consider final velocity v. Once again I am repeating. Take positive x-axis. Take positive x-axis. In this positive x-axis, we are observing an object is at O. At the time is equal to 0. The position of the object is x0. Now the object is started at a time t is equal to 0, and with a velocity v0, it is slowly started and moving along positive x direction. After some time t is equal to t, and now the object is at a position x and its final velocity is v. Now consider an object moving with constant acceleration. Along positive direction of along positive direction of x axis. Once again I am repeating the point. Consider an object moving with constant acceleration along positive direction of x axis. Now velocity at a certain position v is equal v naught plus at or v minus v naught is equal at. Consider equation number 1. Now displacement is equal to average velocity into time. Therefore, the displacement is x minus x naught is equal to average velocity, means final velocity minus initial velocity whole by 2 into time t. Therefore, v plus v naught is equal to 2 into x minus x naught whole by t. Consider this is equation number 2. What we did here? We kept v plus v naught here. As a result, x minus x naught into 2, the t came here downwards. Therefore, v plus v naught is equal to 2 into x minus x naught by t. Okay, I think you understood this step. Now, multiplying equation 1 and equation 2. As a result, we will get v square minus v naught square is equal to 2a into x minus x naught. Consider this is equation number 3. Now this is the velocity position relation. This is the velocity position relation, but x minus x naught, but x minus x naught is equal to distance traveled, or x minus x naught is distance traveled in time in time t. In time t. Therefore, v square minus v naught square is equal to as. Since x minus x naught is equal to s. Therefore, the required equation v square minus v naught square is equal to as. This is equation number 4. My dear students, I hope you understood third equation of motion. Now we are going to discuss one numerical on the third equation of motion. Now go for one numerical. On a foggy day, now we are going to discuss one numerical on the basis of third equation of motion. On a foggy day, two drivers spot each other when they are just 80 meters apart. They are traveling at 72 kilometers per hour and 60 kilometer per hour respectively. Both of them applied brakes. Retarding their cars at the rate of 5 meter per second square. That means this is acceleration. Full stop. Determine whether they avert collision means hitting, collision or not, question mark. My dear students, once again I am repeating the question. On a foggy day, two drivers spot each other when they are just 80 meters apart. They are traveling at 72 kilometers per hour and 60 kilometers per hour respectively. Both of them applied brakes, retarding their cars. Retarding means negative acceleration or decreasing acceleration. Retarding their cars at the rate of 5 meter per second square. Determine whether they avert collision or not. This is the question. Now, first solution we have to solve technically. Now, for the first car, for the first car, the initial velocity u is equal to 72 kilometers per hour. That is equal to 20 meters per second. Now they are applied the brakes. Once they are applied the brakes, what is the final velocity? 0. Now what is the acceleration? The acceleration is called 5. So that is minus 5 meter per second square. Why? They are applied the brakes. Applied the brakes means it is retarding. Retarding means negative acceleration. Negative acceleration means A is equal to minus 5 meter per second square. So that is why this numerical is important. Therefore, V square minus U square is equal to 2AS. What is V? 0 square. Minus what is U? 20 whole square is equal to 2 into minus 5 into, consider the distance is S1. Therefore, S1 is equal to how much? 40 meters. That is equal to distance covered by the first car. Now, case number 2, for the second car. For the second car, U is equal to 60 kilometers per hour. That is equal to 60 into 5 by 18. That is equal to 50 by 3 meter per second. Now what is final velocity? 0. What is acceleration? Minus 5 meter per second square. Now what is the formula? V square minus U square is equal to AS. That means V square minus U square is equal to AS. Now what is V? 0 square. What is U? 50 by 3 whole square is equal to 2 into minus 5 into, consider S2. Therefore here S2 is equal, how much we will get? 27.78 meters. That is equal distance covered by second car. Distance covered by second car. Now what we want? We want total distance. Total distance covered by 2 cars. 2 cars. That is equal to S1 plus S2. That is equal to 40.27.78. That is equal to 67.78 meters. Since this distance is less than the initial distance. What is the initial distance? That is 80 meters. Now 80 meters between 2 cars. Between 2 cars, collision will be avoided. That means they never be under collision. Now I draw a diagram to make you understand. Now take a car 1, take a car 2. Its initial velocity 72, its initial velocity 60. The distance between them is equal to 80. Now both are applied brakes. Now what is the, whenever they are applied brakes, what is the acceleration? That is minus 5 meter per second square. Now once they are applied the brakes, tell me whether they are collide or not. But we got an answer. Once they are applied the brakes, they will get 60. They will get 60 7.78 meters. This is S1 plus S2. The distance traveled by it is S1 after applying the brakes. The distance traveled by this one is S2 after applying the brakes. That means these two will be comes on up to this distance. Okay, that distance is 67.78 meters. That distance is less than 80 meters. Therefore, these two never be collide. Okay, we have to solve the numericals like that. Now, I would like to teach. I already taught one numerical for you. Now I would like to give a numerical as a homework. You please try at your home. Now, numerical number 2. This is homework. A car moving along a car moving along a straight highway a straight highway with speed of 126 kilometer per hour is brought to a stop within a distance of within a distance of 200 meters. Full stop. What is the retardation? What is the retardation what is the retardation of the car assumed uniform now and how long does it take for the car to stop? Question mark. My dear students, once again I am repeating the question. A car moving along a straight highway with a speed of 126 kilometers per hour is brought to a stop within a distance of 200 meters. What is the retardation of the car? Retardation means negative acceleration. Okay? And how long does it take for the car to stop? Here we have to find acceleration. Here we have to find the time t. Okay. So you please try your level best at your home. However, I hope you understood what is the third equation of motion and how to solve the numerical. And you please try this homework. Thank you very much for watching this video. Thank you.